Assalamualaikum and good day. Welcome back to my BCN 2193 Network Technology. 14.4 IP routing table. So I have explained to you the routing table can build up from three methods from three sources, either directly connected network, remote network, or default route. Okay, but all of this can be learned from, of course, directly connected network, learn from directly connected network. But for a remote network and static route, it can be put or configured to our router through static route or dynamic routing protocol. So from this source, it will be put inside our routing table with a several code. You can see here L indicate the address of the IP address assigned to the router interface with a slash prefix 32 or 128 for IPv6. C indicate directly connected network. Okay, when you configure an IP address for the interface, it will be put as a L, but the network will be put as a C with the network prefix properly, which means you configure the IP address 192.168.10.10 slash or subnet mask 255.255.255.0 on interface GI0/1/0. So it will be put as a L with the IP address 192.168.10.10 slash 32 on interface G0/1/0. But we put the network as a C 192.168.0.10.0 slash 24 because we are using subnet mask 255.255.255.0. Okay. But for our manually configured static route, will be indicated with the code of S. And you have an example all here for OSPF routing protocol. OSPF is one of the dynamic routing protocol. And there is addition of S3 or star for a default route. A default route can be from dynamic routing or static routing. Or you can find an example of O star or S star. Okay, there are three principles in order to build up the routing table. First, the router made its decision alone. It doesn't depend. I mean, how they build up. The information may be coming from the other router, but it doesn't depend from the other router in order to build up their routing table. So, their path doesn't determine by the other router. Okay, the information in the routing table of one router does not necessarily match the routing table of another router. Last, the routing information about a path does not provide written routing information. So when we send a data like a ping from router 1, go to router 2, and go router 3, and reach router 4. But from the router 4, in order to return back to router 1, it's not necessary to go through router 2 and router 3. Router 3 and router 2 go back like that flow. It may be connected into another router, router 5, and connect to router 1. So, straight away different from one router to another router. Okay, here is the routing table entry. So for IPv4 and IPv6, they have almost same, but they presented with a several way. Routing IPv4 they presented in one line, but IPv6 they presented in the two line. But their entry is almost the same. Number one is the source route. It will indicate either O, S, C, or L, which means how they build up that entry. From our previous slide, you can see is a C is directly connected. O is a OSPF dynamic routing. Okay. And then second entry, second column in our routing table is a destination network. It provided with a network ID with a slash prefix. Okay, same for IPv6. Network ID with a slash prefix. Okay, in the third entry, third column, administrative distance or AD. Okay, indicate the trustworthiness of the source route. So AD actually relates straight away to their type of source. For the O, they have their own ID. For S, they have their own ID. For C, they have their own ID. So straight away based on their source here. And metric. For each AD, administrative distance, they have their own metric. So why do we need a metric? And why do we need a AD? Okay, AD actually in order to select the most trustworthy protocol, Let's say we learn dynamically from other router with several protocol. Okay, from the router 1, we learn we can reach network X from router 1 through protocol OSPF. But from router 2, also can reach network X, but from directly connected. So, or from OSPF, BGP, EIGRP, and so on. So, they have their own ID. So, a router will select a smallest ID in order to put. So, smaller ID, which means the more trustworthiness. And then, within the same ID, within the same ID, you might learn the same network also. Later, when we do a dynamic routing, you will see this. In order to build up the routing table, we would like to look for the shortest path. We would like to look for the smaller cost. So that's the metric. So for each protocol, they have their own metric. So the metric, we try to look for the lower metric. And next column is a next hook, indicate where that we need to send a data for this network. We must go through this IP address. This IP address is the IP address of the device that directly connected to our router. Okay, number 6 is a route timestamp. Route timestamp, most of the time we use this for the dynamic routing. Whenever they update the dynamic routing, they have the route timestamp. So how long this path has been updated. So it might not be updated for very long, so they need to be refreshed. So they will use this info in order to refresh. Exit interface. This is where most of the time that we use. In order to reach the IP, or in order to reach a device with the IP address 10.0.3.2, we must go through serial 0/1/1. So so the most important thing actually for this network will be sent out through serial 0/1/1. Same like IPv6, okay? So you can read by yourself all about this. To learn about any remote network, they must have at least one active interface. Of course, you can have a remote network if you are not connected to another router. So in order to connect to another router, you must have an active interface. Okay, but your active interface will be provided as a the IP address we put inside our routing table as a L, and the network we put as a C. Now we take a look for a static route. A static route, actually when we indicate our remote network manually to our router. So we configure then, in order to go to that network, you must go through this path. So how to configure then in our router? So we configure in the global configuration with the command IP space route, then network ID and subnet mask. You can see here, IP space route, network ID and subnet mask. For IPv6, we put IPv6 space route space network ID / prefix. Okay. Next, we put the next hook. So take a look for this example, for this diagram. R1 have a directly connected network for 10.0.1.0/24 and 10.0.3.0/24. These two networks we directly add into IP table with a C. But network 10.0.4 is connected into R2, which is R1 doesn't know. So in order for R1 to connect to network 10.0.4, we need to manually configure in R1. So we configure here. So the next hook, actually the IP address of the router that connected to our router. So our router R1 connected to R2. So network 10.0.4.0 are inside R2. So we need to provide IP address of R2, but IP address of next hook is not IP address of interface that connected to network 10.0.4, but the IP address that connected to router 1. So network that connected to router 1 is 10.0.3.0. So it must be 10.0.3. But what is the IP address of the interface of router 2? It is .2. So we put 10.0.3.2. Then we press enter, will be added inside our IP table. Same for IPv6. we put their IPv6 next hoop IP address. So 2001 DB8 column ACAD column 3 double column 2. But for a dynamic routing protocol, each router will be provide their network information to other router. And then when they finish exchange their information, they have converged their network, so they have all the info that they need to know. This is how they represent a network from a dynamic routing protocol. So as you can see here, you have a O which is they are using OSPF. So O here. Okay, 10.0.4.0/24 with the AD110 metric 50 via 10.0.3.2. Okay, last time they update is 24 seconds ago or 24 minutes ago. Okay, through serial 0/1/1. Okay, a default route. Default route actually is a last or gateway of a last hope. Okay, we just configure a static route with the entry network 0.0.0 and their subnet mask is 0.0.0. For IPv6, we just presented with the double colon /0. Okay. Default route, most of the time, we configure for the internet because internet have so many network. We are not able to configure manually every single network, or we do not want to build up an IP table with so many entry of the internet. So that's why we are using our default route. So default route will be 0.0.00. So from point of view R2, in order to go to internet, they must go through ISP. So the command, it can be IP space route, network ID is a 0.0.0, subnet mask is a 0.0.0, through, there's no word through, but I just say that, or via 209.165.200.226, then press enter. That's point of view of R2. And from R1, for R1, in order to reach the internet, they must forward or they must put their default route go to R2. They cannot configure through ISP because ISP is not connected to R1, but R1 have the entry, have connection to R2. Okay, structure of IPv4 routing table I'm already explained to you during last lecture, so I'm not going to read everything. Yes, you can see here there is C directly connected, and then you have a L below that. So L is their IP address of the interface, C is the network, and on the top they have the summary, which means class full of their IP address. So then using 192.168.1.0 network, their class full is the same, 192.168.1.0, because 192.168 is a class C, so they have the class full as class C. So we call that as a parent route. Okay, same for IPv6, but IPv6 we doesn't have a parent route because there is no concept of class full or classless inside IPv6. Okay, I'm already explained to you what is AD. I do not need to move. Okay, this is a number, default standard number for the AD. So I hope after finish with this class, you should be able to memorize some of them. Okay, it's easy for you to remember 0 for directly connected, 1 for static route. So as I said earlier, AD is a trustworthiness. So of course, the most trustfully actually a directly connected, 0. And then the one that we can trust is the one that we statically or we manually configure. They have the AD of 1. But for dynamic routing, they have the variant. They have a multiple value. So EIGRP summary route actually for between network, but internal we are using the 90. So when we do dynamic routing, please remember for EIGRP is a 19. Okay, OSPF is 110. Okay, remember the one that I highlight here. RIP is a 120. This is for internal. But we have also external BGP 20, external EIGRP 120, internal BGP you have 100. BGP usually we most of the time we are not using internal BGP. For internal we are using RIP, OSPF and EIGRP. So please remember EIGRP 90, OSPF 110, and RIP 120. Okay, that's not so many for you to memorize.